This is a star that has been extinguished for over 8.6 billion years, and it is stealing a lot of material from its old star until one day its mass will become so large that it won't be able to handle it, leading to a nuclear explosion that will completely destroy it. This could happen to Sirius in about 7.6 billion years. Sirius, the brightest star in the night sky, hides many secrets. In this video, we will delve into the mysterious world of Sirius. In mid-January after sunset, Sirius rises from the eastern horizon, forming a beautiful winter triangle with Orion's Belt and Canis Minor. Sirius is a binary star system consisting of a blue dwarf star and a white dwarf star. The Sirius we observe is Sirius A, the blue dwarf star. Its mass is about 2.06 times that of the Sun, and its diameter is 1.71 times the Sun's diameter, which is around 2.38 million kilometers. This makes it about 5 times the size of the Sun, capable of containing 6.5 million Earths. Additionally, the surface temperature of Sirius is much higher than the Sun's, about 9,670 degrees Celsius, and its luminosity is 25.4 times that of the Sun. This means Sirius has stronger gravity, a more intense fusion reaction, and releases more energy. On the other hand, Sirius B is a white dwarf, a dead star. Its mass is equal to the Sun's, but its diameter is only 0.0084 times that of the Sun, around 11,692 kilometers. This means it is Earth-sized, but has the mass of the Sun. Its density is extremely high, about 2,400 tons per cubic centimeter, which is 1.72 million times the Sun's average density. The surface temperature of Sirius B is 24,700 degrees Celsius, but its luminosity is only 5.6% of the Sun's luminosity. It is only visible to the naked eye if it is 3 light-years away. Sirius A and B orbit around a common center with an orbital period of about 50 years, and the average distance between them is about 20 astronomical units, roughly the same as the distance from Uranus to the Sun. This distance is relatively close for two stars. Scientists estimate that Sirius is about 240 million years old and is currently in the main sequence star phase. Because Sirius A's mass is larger than the Sun's, its evolution is much faster. Though it is only 240 million years old, scientists say it has already passed through a quarter of its life cycle. Its main sequence phase could last up to 1 billion years. Since stars with larger masses have shorter lifespans, Sirius B, now a white dwarf, was much more massive in its earlier life. Scientists estimate that when Sirius B was born, it had the mass of 5 suns. About 124 million years ago, Sirius B completed its life cycle, first expanding into a red giant and then collapsing into a white dwarf. In approximately 7.6 billion years, Sirius A will enter its red giant phase, and its size will rapidly increase. In the last few thousand years, its outer layer will eject a lot of material into space, and only a hot core will remain, at which point Sirius A will also become a white dwarf. By that time, we will no longer be able to see Sirius. Indian-American astrophysicist Chandrasekhar studied how electron degeneracy pressure prevents white dwarfs from collapsing. However, he also discovered that this pressure only works up to a limit. In other words, white dwarfs have a mass limit, currently recognized as 1.44 times the mass of the Sun, which is called the Chandrasekhar limit. If a white dwarf exceeds this limit, electron degeneracy pressure can no longer prevent further collapse, and the star will explode in a thermonuclear burst. Scientists refer to this as an EA-type supernova. However, an EA-type supernova only occurs if there is a binary star system, with one star being a white dwarf and the other a giant star. In such systems, the white dwarf absorbs material from the giant star, mainly hydrogen. When the white dwarf's mass reaches 1.44 times that of the Sun, a thermonuclear explosion occurs, causing the white dwarf to explode completely. Now, Sirius is such a system. In 7.6 billion years, the aging Sirius A will become a red giant, and Sirius B will start absorbing material from it. When its mass reaches 1.44 times the Sun's mass, an EA-type supernova explosion could happen. Sirius B is one of the most massive white dwarfs known, and is also the closest to us. If Sirius B were to undergo an EA-type supernova explosion, could it impact Earth? If Sirius B really explodes, the 8.6 light-year distance might not be as safe as we think. At that time, we could see the red Sirius in the sky suddenly becoming much brighter. Since the mass limit for an EA-type supernova is 1.44 times the Sun's mass, the energy released during the explosion is almost constant. Scientists have calculated that its absolute magnitude would be around negative 19.3, meaning its brightness would increase 200 million times, which is 5 billion times brighter than the Sun. Even from a distance of 8.6 light-years, its apparent magnitude would reach an astonishing negative 22.2, and Earth's night would suddenly become as bright as day. As visible light, ultraviolet rays, and other radiation reach Earth, the surface and atmospheric temperatures would rise, potentially causing climate changes. However, the risk is currently very low, and even if the explosion does occur, it's 7.6 billion years away. Such a long time gives us plenty of time to think. So there's no need to worry right now. What do you think? Let me know in the comments.